When analysts face a massive, ill-defined strategic problem, the initial reaction is almost always cognitive overwhelm. You are hit with an avalanche of information, variables, and conflicting stakeholder demands, with no obvious starting point. The standard instinct is to immediately start gathering data. We pull reports, interview experts, and run isolated calculations, hoping an answer will naturally emerge from the sheer volume of facts. But aggregating data without a pre-existing logical structure to hold it together actually worsens the problem. It creates false correlations, buries the most critical variables under trivial details, and leads directly to strategic paralysis. Elite problem solvers operate differently. They understand that complex systems cannot be solved holistically. A problem must be structurally cleaved into manageable components before a single piece of data is collected. Raw data is useless without a visual, hierarchical architecture to expose exactly which levers control the system. To map that ambiguity, professional strategists rely on the formal logic tree. Constructing a logic tree requires 3 steps. First, every branch must adhere to a struct constraint known as MISI, mutually exclusive and collectively exhaustive. Second, the tree must be built around a specific mathematical or theoretical cleaving frame to dictate the analytical pathway, turning abstract questions into testable hypotheses. Third, the resulting branches require ruthless prioritization, a process of pruning away the elements that do not directly drive the final outcome. Executing these 3 steps transforms passive observation into a targeted, executable action plan. Consider the conservation of the Pacific salmon ecosystem. As an apex species, their survival impacts marine nutrients in coastal rainforests and commercial fishing economies. Trying to stabilize their population involves managing interannual variation, unpredictable ocean conditions, and the divergent behaviors of multiple subspecies across thousands of miles. This chart shows a component tree, the foundational step to mapping the basic factors of decline. We list watersheds, the ocean environment, commercial fisheries, hatcheries, consumer behavior, and government policy. This gives us a landscape, but it fails the MISI constraint. MISI requires branches to be mutually exclusive, meaning no overlapping variables. Look closely at the government policy branch. Government policy regulates commercial fisheries and manages hatcheries. By placing it as an independent branch alongside things it controls, we create overlaps. MISI also requires the tree to be collectively exhaustive. The branches combined must encompass 100% of the problem space, ensuring no blind spots remain. To fix this, we reorganize the component tree into a rigorous hypothesis tree. We nest fisheries and policy under specific variables, separating local watershed management from international ocean treaties. Failing the MISI test causes analytical double counting. If your variables overlap, your data will overlap, rendering any strategic hypotheses you pull from that tree invalid. We see the same structural requirement in corporate strategy. In the early 1980s, the hardware retailer Hetchinger found itself competing against a new rival, Home Depot. On paper, both companies were generating near-identical returns on invested capital, or ROIC. Looking only at top-level aggregate metrics disguised the actual competitive dynamic at play. To see what was actually happening, analysts had to apply a cleaving frame, using a specific mathematical relationship to divide the problem into absolute truths. This chart shows the deductive ROIC logic tree. It forces the top-line metric to split strictly into profit margin and asset productivity, which then break down into specific revenues, costs, and capital variables. Inputting Hetchinger's data shows a thick, dominant profit margin branch. They ran clean showrooms with high retail prices and extensive backroom storage. But inputting Home Depot's financial data into the exact same tree structure yields a different shape. Their profit margin branch shrinks rapidly, representing prices up to 18% lower, while their asset productivity branch swells massively to compensate. Because the tree is mathematically complete, Home Depot's ability to maintain overall returns despite low prices forces the analyst to look directly at the asset productivity node to find the mechanical difference. Isolating that specific branch reveals an entirely different operational model. Home Depot was operating out of bare-bones warehouses. They bypassed central warehousing using cross-stocking directly from suppliers and stacked inventory on 20-foot racks right on the retail floor.
This stripped out distribution costs and pushed their asset turnover metrics upward. Hetchinger saw the low prices but failed to map the deductive structure behind them. They tried to match Home Depot on price without changing their high overhead supply chain, a miscalculation that drove them into bankruptcy. Selecting the correct mathematical cleaving frame exposes structural advantages that standard data aggregations perfectly disguise. Even with a perfectly mapped MECE tree, attempting to analyze and execute on every single branch will paralyze an organization. The third step of problem solving is strategic pruning. We map the tree against a 2x2 matrix. The vertical axis measures a variable's total impact, and the horizontal axis measures our ability to influence it. Every branch on the logic tree is detached and plotted onto this grid based on those two criteria. In the salmon conservation case, we evaluate ocean conditions. We know that climate-driven ocean temperatures dictate the food supply for juvenile salmon, so its impact is massive. But a private foundation has zero ability to control global ocean temperatures over a 15-year grant cycle. Therefore, it sits at 0 on the influence axis. The matrix dictates that this branch must be entirely discarded from the work plan. By isolating only the variables that land in the high-impact, high-influence quadrant, you strip away the noise and locate your critical path. Elite strategy is defined just as much by the data you explicitly choose to ignore as the data you choose to analyze. Disaggregating complexity is a disciplined, iterative loop. It starts by acknowledging that systemic ambiguity cannot be tackled head-on. You build an initial component tree to visualize the landscape. You apply a deductive cleaving frame to enforce mathematical rigor and isolate the true mechanical levers. And you map those branches to a matrix to mercilessly prune unactionable variables, leaving only the critical path. An analyst's ultimate competitive advantage is not software capability or the volume of data they process. It is their structural architecture. This framework prevents resources from being burned on the visible symptoms rather than the underlying root causes. By mastering MEC logic trees, professionals bypass the noise of complex data and surgically isolate the precise vulnerabilities of any strategic challenge.